it's Miss McGann, and today we're talking about scientific notation. So when we have super, super big numbers, really, really small numbers, it's easier for us to express it in scientific notation versus writing out all of those digits or all of those place values and zeros. So we're going to take some smaller examples and show what does this look like for science, or how does this help us with writing numbers more simple. So we have 73,000 up here. I know it's in green, so it's a little harder for you to see. But with scientific notation, the rules are when you write a number in scientific notation, the first number has to be between 1 and 10. So it has to be greater than 1, smaller than 10. So you should have one digit in the ones place. You shouldn't have two numbers before the decimal. And then it'll be times 10 to some power. And so if we have the number 73,000, the way that we can write it in scientific notation is getting 73,000 down to keeping the digits, keeping the numbers in the same order, down to a number that's between 1 and 10. So if I put my decimal here between the 7 and the 3, that would be 7.3. 7.3 is between 1 and 10 on a number line. So we can use that as our first number. So we have 7.3. Make that a little darker so you can see it. And then we're going to do times 10 to some power. The number, the exponent that we use is going to tell us how many times we move that decimal. So if it's a positive number, we're going to move our decimal to the right. If we put a negative exponent, we're going to move our decimal to the left. So if our decimal is here, but we want it to become 73,000, we're going to have to move our decimal how many spaces? 1, 2, 3, 4. We have to move our decimal 4 spaces to get this number to become 73,000. So the goal of scientific notation is to represent larger numbers or smaller numbers in a more easier, manageable way. So 7.3 times 10 to the fourth would be equivalent. It's the same as 73,000, just written in scientific notation. So I know it seems about the same number of digits, but the goal is that when we get up to bigger numbers, 20 spaces, 20 digits, that it would just save us some time. We'd be able to make it simpler. Let's try this one. We have 0.00974. We want to write that in scientific notation. So if we keep all of the digits in the same order, how can we write a number out of this that's going to be a number between 1 and 10 on a number line? So our first number, what we are going to multiply by, has to be a number between 1 and 10. So I think, what about 97.4? Is 97.4 between 1 and 10 on a number line? No. Okay, that's not going to work. What about 974? Oh, no. 9.74? Yes, that could work. So if we're going to put our decimal here, we got to figure out how many spaces do we move it to get it to be the original number. So I would write 9.74 times 10. It's always times 10 to some exponent. So if we want to get this, we want the number to end up being 0.00974. How many spaces are we going to move our decimal? 3. We're going to move it 3. Which direction? To the left. So when we move it to the left, we're going to have a negative exponent. When we move it to the right, it's going to be positive. So 9.74 times 10 to the negative 3 is the answer. Awesome. Let's write this number. So these were in standard or the regular decimal notation, and then we wrote them in scientific notation. Now this is in scientific notation, and we're going to switch it that way. So we want to make it 5.8 times 10 to the 20th. So it's a positive number, so we're going to move our decimal 20 spaces to the right. I'm going to start over here. It might be easier. 5, 8, and then we're going to have to do 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Why did I say 19? Because we already have to move our decimal 1 to go past the 8. and then 1 plus 19 more would equal 20. So would you rather write out this number or this number? I'm saying scientific notation. That's why it's so important, because when we get these really, really big numbers, really, really small numbers, we're talking about space or microbacteria. It's a lot easier to do it in scientific notation. Let's check these numbers. Are these written in scientific notation? So 16.8 times 10 to the negative third. Well, I know we got to do times 10 to some exponent, and it can be positive or negative. So that seems okay. Is this first number okay? 16.8? Is that a number between 1 and 10 on a number line? No. So what would we have to do to make it scientific notation? Move it 1 here. So we could make it 1.68. Yeah, that works. But then we moved it 1 more. So what do we have to do to our exponent so we can make sure we end up with the same number? If we have 16.8 times 10 to the negative 3, let's see. We want the number to end up being something like this. 1, 2, 3. So that's what our end number should be. So now if we have this, how many spaces do we have to move to get to be a number like that? 0.0168. We'd have to move it 2 spaces, I'd say. 1, 2, to get it to be, I know it's hard for you to see, 0.0168. So we're going to do negative 2. So notice we have to change our exponent when we change the decimal location, because the end goal is we want to end up with the same number. So this ended up 0.0168. This one ends up 0.0168. It was just we had our decimal in a different spot, so that's why we had to change our exponents. All right, this one, is this written in scientific notation? Once again, times 10 to some power. That's okay, we can have a double-digit exponent. We had a double-digit exponent here. But is this first number right? Mm-mm. We need to make it a number between 1 and 10 on a number line. I think 4.3 is between 1 and 10. So we'll do 4.3 times 10, and we're going to have to change our exponent because we move our decimal, we have to change it. So I noticed up here when we were going to the left, we increased the exponent number. So I wonder if when we move it to the right, if we have to decrease our exponent number. Would 4.3 times 10 to the 10th be the same as 0.43 times 10 to the 11th? Are we just taking out an extra step that they moved, but we're still going to end up with the same number? If you do it on your paper, you'll notice that it is going to end up being the same number. So when we have to move our decimal, when we move our decimal point over to the right, we're going to go down an exponent value. And when we move it over to the left, we're going to increase our exponent value, or we're going to make it more positive. That makes sense. I know when you're looking at negatives, you're like, increasing? It's hard sometimes to see that. Okay, awesome. And this last one, is this written in scientific notation? I don't see times 10 to anything, so I don't think so. 5.3 to the 6th power is not the same as 5.3 times 10 to the 6th. This would be 5.3 times 5.3 times 5.3. So that is not written in scientific notation. So I'm just going to cross that off altogether. Once you understand the concept of scientific notation, multiplying, dividing, adding, and subtracting, we can kind of use these different strategies to find our numbers. And we'll kind of break it down to pieces in future videos. But let me know if you guys have any questions about scientific notation.